So, we're all trying to do the right thing, right? We're plugging in electric cars, putting up solar panels, switching over to efficient heat pumps. But here's the thing. All this amazing progress is creating this huge invisible traffic jam on our power grid. And that grid, well, it was built for a totally different world. So how in the world do we fix this? Well, over the next few minutes, that's exactly what we're going to dive into. We'll look at why our grid is getting so stressed out, what's really stopping us from just fixing it, and then we'll check out a really clever new platform that's designed to clear up all this congestion. We'll even see how it did in a real-world stress test. All right, so what's the fundamental issue here? You can boil it down to this. We're trying to run 21st century energy habits on a 20th century road system. Our grid was designed for a simple time, with big power plants sending electricity one way out to everyone. That's it. And honestly, the best way to picture what's happening is to think about a highway during rush hour. When way too much electricity tries to cram through one section of the grid all at once, you get a jam. And in the energy world, they have a name for that: congestion. So what does congestion actually mean for the grid? Well, it's not just a little slowdown. It can physically damage really expensive critical hardware. We're talking transformers overheating or voltage levels dropping so much that your lights might flicker or your sensitive electronics could get fried. It's a serious problem. And here's the crazy part. The things causing all this congestion are the very things we want more of. More solar power, more wind farms, more EVs. The problem isn't the tech itself. It's that they create these wild, unpredictable, two-way flows of power. Your solar panels are pushing energy back onto the grid. A whole neighborhood plugging in their cars at 6 p.m. creates this massive, sudden spike in demand. The old grid was a one-way street. It just wasn't built for this kind of chaos. Okay, so that brings us to the big question, right? If we know what's causing the traffic jams, why is it so darn hard to clear them up? It turns out there are two major bottlenecks that are really getting in the way. So what are they? Researchers have really zeroed in on two very tricky challenges that are holding everything up. Problem number one is something called low liquidity. Think about it like this. To fix a traffic jam, you need options, right? Alternate routes, or maybe cars that can wait to travel. In the energy world, that's called flexibility. And right now, there just aren't enough of these options for sale exactly where and when the grid operators need them. Then there's problem number two, adverse impacts. And this is the real kicker. It's when you try to fix one problem, but you accidentally create an even bigger one somewhere else. Kind of like diverting traffic off a clogged highway, only to cause a 10-car pileup on a quiet side street. So let's start with that first problem, not having enough options. How do you fix that? Well, the solution is pretty clever. It's about finding more of that flexibility by tapping into markets that already exist, but we just haven't been using them for this. And the key insight from researchers is that we need to build a new kind of digital platform, one that can connect everybody, from a giant power plant all the way down to your neighbor's EV charger, and let them all play a part in solving these grid-scale traffic jams. And this really shows the whole idea perfectly. This new platform acts like a central hub, a digital matchmaker, if you will. It connects the folks who have flexibility to offer, say a big factory that can pause a production line for 30 nights, with the grid operators who desperately need it. And it links them all up to the big established energy markets. So let's look under the hood of this platform. It basically has four key jobs. First, there's a flexibility register, which is just a big catalog of anyone and anything that can offer help. Second, a single market interface. This is the gateway that connects that catalog to the big leagues, to the existing energy markets. Third, you've got the TSO-DSO coordination module. This is the smart referee we're going to talk more about in a second. And finally, the settlement unit, the part that makes sure everybody gets paid. And here's the genius of it, Instead of trying to build a whole new marketplace from scratch, which is super hard and might not get enough buyers and sellers, this platform just plugs right into huge markets that already exist and are buzzing with activity. And just like that, you've solved the low liquidity problem. The grid operators suddenly have a much, much bigger toolbox to work with. Okay, so that's how we get more options on the table. But what about that second really tricky problem? How do you stop your solution from accidentally making things worse? Well, for that, you need a smart referee. This is where that TSO-DSO coordination module is so critical. See, the TSOs, they run the big energy highways. And the DSOs, they manage all the local streets. This platform lets them team up and check every single potential deal before it gets the green light. It's basically air traffic control for the power grid, making sure every single move is safe before it happens. And here's how that safety check actually works. When a whole bunch of these flexibility offers or bids come in, the system runs a super fast simulation. It calculates what would happen to the grid if all of them were accepted. If it spots a potential new problem, a new traffic jam, it starts kicking bids out, starting with the most expensive ones first, until the simulation shows the network is safe again. Only then are the safe, qualified bids passed along. And check this out. The data shows just how powerful this smart referee approach is. Using simpler methods, you might only be able to safely use about 62% of the grid's total capacity. But with this more advanced, data-driven system, that number jumps to almost 90%. I mean, that is a massive, massive improvement. It means we can get way more clean energy flowing through the wires we already have just by being smarter about it. Now, all of this sounds fantastic in a lab, but the real question is, does it work out in the messy, real world? Well, a team of researchers did exactly that. They put this platform to the test in a huge demonstration project across Finland, Estonia, and Latvia. Let's zoom in on one specific example. The system detected a voltage problem and asked a large leisure center to cut its power use. And you can see from that first dip in the graph, it worked like a charm. They dropped their demand by 180 kilowatts. But look what happens an hour later. You get this huge 128 kilowatt spike, a rebound effect, as all the center's heat pumps worked overtime to catch up. That's the kind of real-world challenge you only discover by actually doing it. So, what was the final score? How well did it do overall? During the tests, the platform was able to completely solve about a quarter of all the congestion problems they faced. Now, 25% might not sound like a home run, but in the complex world of grid management, that is a huge win. It proves the concept works, while also showing us, hey, this isn't a magic wand that fixes everything. And the test taught everyone some incredibly valuable lessons. First, we've got to have realistic expectations. A market-based system won't solve every single jam. Second, different devices, like those heat pumps, have their own weird quirks, like that rebound effect that you have to learn to manage. And finally, there's a real learning curve for everyone involved. It takes experience for people to get good at bidding just the right amount of flexibility they can actually deliver. So let's wrap all this up. The big takeaway is that a central platform like this really can unlock a ton of flexibility by tapping into markets that are already out there. But, and this is a big but, you absolutely need that smart coordination between grid operators to make sure you're not just making things worse. The real-world data shows this approach works. It's not a silver bullet, but it is a massive and promising step towards the smarter, more dynamic grid we're going to need. And that leaves us with one final thought. The pace of this change isn't slowing down. It's getting faster. More and more, every day, we're all becoming active players in this energy system. So the real question isn't if this is happening, but are we building the digital intelligence, the smart platforms like the one we just saw, fast enough to keep up with it all?